Hello everyone, thanks for joining and thanks for watching. We're on day 3 of Advent of Code and let's get to it. Before we get started, I wanted to show you I have actually published my day 2 solution from yesterday up to public GitHub repo Joe Skeen / Advent of Code 2022. I'll try to get the 01 up there as well. That was on a different computer, so I just haven't gotten around to doing that yet. But I'll be publishing my solutions up there as we go. All right, let's hop over to day 3. Excited to see what this is. Day 3, Rucksack Reorganization. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of those 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. Okay, meant to go in exactly one of the 2 compartments. Got it, okay. The elves have made a list of all of the items currently in each rucksack, your puzzle input. But they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, A and A refer to different types of items, okay? The list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represents items in the first compartment, while the second half of the characters represent items in the second compartment. All right. For example, suppose you have the following list of contents from 6 rucksacks. Okay. The first rucksack contains the items blah, 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 which means its first compartment contains these ones, while the second contains those ones. Okay, so it's splitting it in half, first half, second half. Okay. The only item type that appears in both compartments is lowercase p. Got it. Okay. Second rucksack's compartments contain these and these. The only item type that appears in both compartments is uppercase L. Third rucksack's compartments contain these. Only common item is uppercase P. Fourth compartments only share VTS. Okay. To help prioritize the rearrangement, every item type is converted to a priority. Lowercase item types A through Z have priorities 1 through 26. Uppercase items have 27 through 52. In the above example, the priority of the item type that appears in both compartments of each rucksack is priority of the item type appears in both compartments. Okay, yeah. So 16 for P, 38 L, etc. And the sum of those is 157. Okay, so it sounds like you need to find out which item appears in both compartments, convert that to its priority, and then add all of those priorities up. Okay. That seems fairly straightforward. Let's get to it. Let's grab our puzzle input. And I'm going to come over here. We'll create a new folder in 2022 for 03. And in here, we are going to put index.txt. And we're going to put example.1.txt or .input.txt. So this is our example input here. And let's duplicate this, copy and paste and rename output. And the answer for that one is 157. All right. Oh, the output. There we go. Okay. And then finally, we need a solve.mjs file. Okay, and it needs to export to functions. So we will say function solve1 lines and return 0. Export function solve2 lines and return 0. All right. And I guess we need to create some files for the second part so it doesn't blow up. I probably haven't accounted for that in my testing harness yet. So we'll put a 2 there and a 2 output. And we'll just leave them blank for now. So delete that and delete this. So we've got the, I must have worked that. Okay, copy, paste. All right, so we have the right stuff for 1, and for 2, we have nothing. And then we have our puzzle input and our solve file. I just want to make sure that this works. So we'll say node index.mjs. Cool. Looks like my testing harness is working. Hooray. Okay, so let's hop into the actual solve here. So I'm going to close all except for this one. Okay, so we've got our lines, and actually maybe I'll just open the example input to the side here so we can take a look at it. So each line is going to be an entire thing. Just a second, let me move myself over a little bit. It looks like I'm overlapping the text a little bit, and I don't want to do that. There we go. That should be better. Okay, so we've got this line. We want to split it into a character array. In JavaScript, the easiest way I know to do that would just be to split it on nothing. So we're going to split on nothing, and that gives us the characters. But of course, actually, we don't even need to split it into a character array yet. Well, we might as well, because we're going to be analyzing each character in the array. Okay, so we'll say const chars equals that. And then we want to divide this array into two parts. So we're going to do a slice. So we can say const compartment1 is going to be chars.slice. I could have done it with substring before I divided it, or before I split it, but that's okay. Slice from 0 to chars.length divided by 2. That should give us the first half. And then from here, we can do slice starting at that index. And I believe that will do what we want it to do. It does not like that. Okay, I'm not in TypeScript. It's not giving me all the developer experience goodness that I love. All right, so we've got compartment 1, compartment 2. Let's just console log those out and make sure that we're on the right track. Console.log, compartment 1, compartment 2, and we can run this again. Lines.split is not a function. Oh, right. We need to be iterating on each of these lines. So we'll do lines.forEach, and we'll say line okay. Hopefully that fixes my problem. Chars dot dot lines dot length. That's kind of funny. I'll move this over a little bit here. Okay, hopefully that works. And it looks like we are getting the same number of characters in each compartment, and they're not the same characters, which is good. Yeah, this looks correct according to the description in the puzzle. Okay, so what's next? So we need to figure out which character exists in both of them. So to do that, we could probably just look at each character in the first compartment and see if it exists in the second compartment. So we could say, I am realizing more and more I could have done this just as all string stuff, but that's okay. We'll continue on with this. We'll say compartment1.forEach, and we'll say we've got a char, and we will say, actually, since we know there's only going to be one, maybe we could just do .find. So it will return the first thing that it finds that satisfies this condition, which is just a function that returns true false. So we will say compartment2.includes char. Okay. So this will be const in both. try that. We'll console log that in both. All right, let's try it. And we have a problem. It says compartment2.includes is not a function, which is really, really interesting to me. It came through as an array. I would expect, oh, whoops, this first of all includes, but includes is, oh, includes, includes, there we go. Okay, let's see how we did. So PLPVTS, what did we have here? PLPVTS. Okay, that was easy enough. Now we just need to map them to their own value. Okay, so what we could do for that, there's a number of ways we could do it. We could manually create a mapping like we did yesterday for rock, paper, scissors for each of the letters. But since they're all adjacent to each other, both in the alphabet as well as strings themselves, what we could do is we could map, we could just do some math to find out what it is. So we know that, so let's see, I guess we need to first figure out, is this an uppercase or lowercase, right? Because lowercase goes 1 through 26. So we'll say const lowercase a equals 1 and const uppercase a equals 27. Was that right? Yeah. Okay. So we want to basically figure out if this in both thing is either uppercase or lowercase. I'm not aware of anything in JavaScript that says is it uppercase or is it lowercase. There is a lowercase and uppercase function that we could call. So we could say, maybe we'll just put this out here. We'll say const is uppercase or is lowercase, since that is the lower value here. Is lowercase is going to be, you give it a char, and it's going to take the char and to lowercase it, and then it's going to see if it is equal to the char. If it is, then we know that the char itself is lowercase. Okay, so now, and these things don't change between cases, so we can put them up here as well. Okay, so let's try this. We'll say if is lowercase, and we'll say in both, and else. I just want to double check that I got this correct, because I work in so many languages and I'm trying to remember if to lowercase. Okay. To lowercase. Okay, I got that right. Okay. Close that out. Okay, if it's lowercase, then we want to, well, first of all, we want to figure out what number this is. We'll say const let's see, const char code is probably not a bad way of doing it. So we'll say in both dot, and in a string, let's go back to Node for a second, we can say char code at. at 0 because it's only one character. Char code at 0. One letter. I don't know if I said one number or not. Okay. Char code at, that will give us the char code there. So let's do a little bit of discovery here. What is the char code for the lowercase a? It's 97, right? So maybe instead of saying lowercase a is 1, what we could say is const lowercase, what do we call it? Like the amount that we need to subtract from the char code to get to that amount. So we'll say lowercase differential. That's kind of a big word. So basically we want to say what number do we subtract from 97 to get 1, which is going to be 96, right? So basically a is equal to 97. 97 minus 96 equals 1, which is what we want. Okay, so let's try that. And then similarly for an uppercase differential, uppercase A is 65. So we can say const uppercase differential is going to be, well, let's work that out. So uppercase A is equal to 65, and we're going to say 65 minus what equals 27. You know, I could have just used the math here and just said, okay, we're going to say a dot char code at 0 minus lowercase a, and that will give us the same thing because our a dot char code at 0 is 97, and then I subtract 1 from it. That gives us our 96 that gets stored into here. So actually, yeah, I like that better and requires less human error on my part. So I can just say capital A, whoops, and uppercase A. Okay. So we've got our lowercase differential and our uppercase differential. So now we can just say this is our char code. If it's lowercase, we're going to say, well, maybe we'll just say let value because it could be either one of these. And we'll say value is going to equal the char code minus the lowercase differential. And in this case, we're going to say the value is going to be equal to the char code minus the uppercase differential. And let's see, will that work for everything? So the biggest number we could ever have is 52 for the value, and that's less than 65, which is the lower bound of the capital letters. So I think we should be fine. But let's just, for fun, console log out. We'll just do an object and we'll say char code and value. Make sure that we're doing this correct. Whoops. And we've got a problem. Char is not defined. Oh, it's called in both. Okay, so are we still on the right track? So we look here, 16 is lowercase p, 38, 42, 22, 20, and 19. All right, this is looking good. So now they just want the sum of all those, right? So we're going to come back here, and we can create a sum variable. So we'll say let sum equals 0. And once we get the value, we're going to say sum plus equals value. And then return the sum. Let's try it. Aha! Output is correct, 157. Okay, so my question is, oh, I must have disabled it in index.mjs. Let's see. Yes, I did. And I don't have any console logs in here anymore, so shouldn't go crazy when I run it. Oh, and it blew up. It blew up royally. Input. Oh, index. I'm doing great here. Input.text. Yep. Okay, so it's saying that my answer is 8139. Let's see if that is correct. That is correct. Woohoo! All right. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. Okay, that is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. Wait, what? Okay, all of them have B. At most 2 of the elves will be carrying any other item type. Okay, the problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, no one wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Okay? Each set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 items. Okay, so this is the same example here, okay? And the second group are these 3. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. This must be their badges. In the second group, their badge type must be Z. Priorities for these items must still be found in order to register the sticker attachment efforts. Here they are 18 for the first group, 52 for the second group. The sum of these is 70. Okay. All right, let's try that out. Okay. Oh, okay. I was getting a little hung up on this part before, but I get what this is saying. They're saying that there will only ever be one item that is carried by all 3. And if there's anything repeated, it will only be repeated in at most 2 of the 3 elves. Got it. Okay. Okay, I think we can deal with that. Let's actually take the example input for part 2, and the answer is going to be 70 on this one. I'll just keep that up because it's already there, and we can close that. Okay, so part 2, this can still be useful for us. Although maybe it would be even better to have a valuation function. So we'll say const get value is going to be a function that takes in a char and is going to return the value of that item. So we'll say char. Oh, but we need to get the char code from it first. Char code equals char.charcode at. Okay, so we've got that. We can substitute our get value here, and it should still work. So we'll say const value equals get value for in both. And it blew up. It says value is not defined. Right. So we can just say return this and return that. Okay, so we still get the correct answer there. Okay, so with that, we could actually bring all of this outside of our solve function, and it still should work, because we're going to use it also in part 2. Okay, so part 2, we need to, instead of going line by line, we want to go 3 lines at a time. For this, I'm just going to do a for loop here. We'll say let I equal 0, I is less than lines.length. And this time we're going to say, instead of I++ like you normally would see, we're going to say I plus equals 3. That way we can basically process 3 items for 1 loop. Okay, so we'll say const rucsacks is going to be lines.slice starting at I, and end is going to be I plus 3. Okay, so that should give us our 3 rucsacks. So I think again we can just iterate through the first rucksack. We don't need to iterate through all of the other ones as well. So let's do, we'll say const first rucksack chars is going to be equal to rucksacks at 0. And then we're going to, let's see, dot split on nothing, so we get the characters. Okay, so now that we've gotten the characters, we are going to, let's see, split on the empty string. We'll just say const shared item is going to be first rucksack chars dot find, again, where the char is, oops, and we'll say return rucksacks sub 1, so position 1 dot includes the char, and the rucksack at index 2 also includes the char. Okay, so let's console.log shared item and see what we get. Okay, R and Z. R and Z, uppercase Z, sweet. Okay, we're on the right track here. So now we just need to use the same function that we created before to get the value of that item. So we can say let total equal 0, and then we will say total plus equals get value for shared item. And then we'll say return total. Okay, let's see what happens when we run this. Correct, and 2668 is our total. So let's come back here and submit. Wow, that was a quick one. All right, hopefully you understood what was going on there. I know I tend to go a little fast sometimes, and this was a very fast solve. If you have any questions, feel free to reach out in the comments. And again, I'll be submitting this code up to GitHub so that you can take a look at it, experiment with it, and all that good stuff. So thanks again for watching, and hope to see you next time.